Hi Year 10s, in this video I'm going to run through how we use a regression equation. In our last lesson we were looking at how to establish that equation. We're going to look at how we make a prediction with that equation. I'm going to use the one that we got in our last lesson, which was the test mark, or it linked to the test mark and the time spent studying. What this regression equation gives us is an ability to substitute values into it and then have a look at what the test mark would be, or what a predicted test mark would be. And we can even look at the predicted time that we need to study to obtain a particular test mark, and that is based on the data that we've got. So that is based on this data that we had up here. Remember what we did was I'll just go to this page, we fit a line to the data that we plotted, and then we established what the two coordinates that lie on that line, what a couple of those are, and we use that CAS technique to generate that line. And that's what I've got on this other page as well. There's the same equation. Now, we're going to make predictions. I'll talk about interpolation and extrapolation soon, and what those two things mean in terms of reliability of a prediction. First, though, I'll show you how to predict. So we've got test mark and we've got time spent studying. And what you'll notice here is we're asked to predict a test mark when the time studying was 4.5 hours. So this here is our time studying. Now, what I want you to do is have a look at your equation and have a look where time studying is. It's just here. We are going to substitute 4.5 in its place, so where it lives in that equation. In other words, the test mark is going to be equal to 6.67 multiplied by 4.5, because it's 6.67 times the time spent studying, which is 4.5, and then we're going to add 38.67. Let's get our calculators out and establish what that is going to give us. So 6.67 multiplied by 4.5, and then we were adding 38.67. And there we have it. So our predicted score is 68.685. Let's go back. But if we have a look at our original data, you'll notice that was rounded to the nearest whole number. So I might just round this one as well. I've got my answer, but approximately that equals 69%. So we predict then, using this data, that if you study for about 4.5 hours, you might then obtain a mark of around about 69%. Now, of course, that may not happen in reality, but that's the thing about data. It's giving us a prediction only, and that prediction is only based on this data, nothing else. There are other variables, obviously, when it comes to test marks and the amount of time spent studying. But data doesn't work exactly like 100% correct prediction. We obviously keep in mind that it's not perfect. The next prediction is a little bit different because what you'll notice is we're asked for the number of hours of study required for obtaining a test mark of 100%. So if we want 100%, if we put that here, 100 for this bit, we're asking what time spent studying needs to go there to make this equation true. So what I'm going to do then is I'm going to substitute again, but I'm going to substitute the 100 for test mark. I'll leave the percent out for the moment, since we didn't have percent in our actual data. We didn't put it in as, say, 100 over, sorry, we didn't put it in as this data, 54 over 100. We put it in as 54, and so that means I put it in here as 100. Now, I don't know the time spent studying, so I'm just going to call that time in my rule. And then I'm going to add 38.67. So I need to solve for time here. Now you can use your calculator to do that. I'm going to do that now. So we'll go menu and then 1 for solve. Now we want 100 equaling 6.67 times by the time, I'm just going to call it t, and then adding 38.67. We'll put a comma because we will need to tell the calculator what we're solving for. We're solving for t, and then we'll press enter. So as you can see, we've got just over 9 hours study to achieve that result, according to the data. So I'll put 9.91 time equals 9.91 ... because it keeps going hours. So approximately, I'll just put a little curly equal sign, approximately 9 hours study will generate that mark of 100%. Now, I'll just go back a step to what these two terms mean. When we're doing a prediction, we can actually assign or classify our predictions in two different ways, so two categories. If you are using a data or piece of data, or a value I should say, if you are using a value that is within the range of your data, I'll show you what I mean by that. This 4.5 hours study time, we go up to our data up here. You notice that the lowest starting time was 1 hour and the highest starting time was 8 hours. If I'm making a prediction using a value for time spent studying that's in between our lowest and our highest result, then I'm doing something called interpolation. So I'm looking at within this range of the data that I've got here. If I go beyond my data, now if we have a look at the second one, this second one does that. 4.5 was between 1 and 8, so that was interpolation. This one is 100%. Now if we have a look at our lowest percentage and against our highest percentage, our lowest was 48 and our highest was here 98. So if our prediction, our test mark that we were given to predict with was 100%, notice how that is higher than our highest value we had. So 100 being greater than 98. That means we're actually making a prediction beyond the data that we have. And when you have that, so outside the data range, when you have that situation, you are talking about something called extrapolation. So the best way to approach these questions, if you're asked, is it interpolation or is it extrapolation, you need to look at the value you were given. So not the one you found, the one that you were given. Then have a look back up at your data set and see if it's in that range. If it's not, it's extrapolation. If it is, it's interpolation. The reason we want to discuss this is because in extrapolation can be less reliable. So sometimes we look at our predictions and we ask ourselves, which of these is a reliable prediction? We tend to have more reliability or accuracy in our predictions if we're using the actual data in front of us. If we're extrapolating, what we're doing is we're making an assumption. We're making an assumption that the data continues, the pattern. So we're making an assumption there's a relationship beyond the data that we have, but we're also making an assumption that that relationship is linear, which not all the time when you extrapolate is that true. So what's most important is that you recognize when you are extrapolating, it can be less reliable than when you are interpolating. So I'm going to finish there and you're going to now be able to complete some of the exercises where you are required to make some predictions.